This telescope isn't really meant for planetary imaging, but come check this out if you're interested to see what it can do. Now, if you've watched any of my other videos, and if you haven't, please go check them out, you might be thinking, well, that doesn't make any sense. How is it that this telescope can image deep space objects that are hundreds and thousands and millions of light years away, but it can't do a great job imaging Jupiter when it's right here in our backyard? Well, let me explain. These telescopes specialize in faint, dim objects and staring at them for a long period of time to slowly capture light from extremely dim objects. The planets are close and bright. So when we look at planets through the Seestar, they tend to just look like really bright stars, and they can be kind of disappointing to look at. You don't get to see the rings of Saturn and the stripes on Jupiter. But if we play with the settings, we can pull it out a little bit. So follow along this video if you want to see how. Okay, let's go Jupiter hunting. So when you're going to the planets, you're going to use this middle button that says solar system. And then from there, find your planet and select go to. Now, I also just want to take this moment to point out, you can also use this to see which planets are currently available and visible to view. As you can see right now, Jupiter is at 75 degrees. Essentially, it's almost at, straight up, very high in the sky. Think of the land as a flat plane. We're up 75 degrees from there. And Uranus is also quite high. Venus is only at 9 degrees above the horizon, which means it's likely going to be obscured by trees and buildings and things. And then all the other planets are not currently visible in the night sky. But let's go ahead and go to Jupiter. All right, and there you have it. First thing I'm going to do is I'm going to click the center target up in the upper right-hand section of the screen. That is supposed to, you'll notice the screen moved just ever so slightly. It's essentially keeping the Jupiter centered in the image. Now, again, as I mentioned, it really ultimately just looks like a really bright star, but there is some fun stuff here, mainly the 4 moons. There's one that's really, really close to Jupiter, maybe partially behind it there that we can't see very well. But you can really distinctly see 3 of Jupiter's moons right there. Those are the Galilean satellites. It was really interesting. I was at a star party the other night, and a kid was able to give me the names of all 4 of the Galilean satellites, which I was extremely impressed. But if you are curious to know, they are called Io, Europa, Ganymede, and Callisto. I had to think there for a minute about the last one. So, but again, not a super exciting image here, but we can also zoom in a little bit more. There we have it. This is Jupiter all the way zoomed in. We're going to center our target again there. Now, in order for us to try and see some of the details in Jupiter and try to see those bands, so now we are going to change our viewing to this video mode right here. And then we're going to say raw. I'm going to check this box that says raw, which is basically going to save my video files into a folder where I can stack them together later. That'll make more sense in a minute. Okay, then I am going to go to adjust, and I'm going to click this box that says manual. And I'm going to take the exposure and the gain and turn them almost all the way down. Okay, and as you can see, if we zoom in on that a little bit, it's letting in a lot less light now, but we're almost able to, every once in a while, we see a flash of what looks like could be a band on there. So it's still not a stellar image, but we're going to take a 10-second video of this target, and then we're going to stack it and see what it turns into. So now we're going to go to my album, select Seestar. We're going to go to our planetary video, select it, and then click this button in the upper right hand corner that says stack. Okay, this turned out absolutely beautiful, even better than I expected. And so now we're going to go ahead and click on this edit button. And from here we can play. We'll zoom in a little bit more on Jupiter here so we can see what we're looking at. Oh, we definitely don't want more brightness because that's going to make it even harder to see those bands. I think I'm going to turn the brightness down a bit and see if we can get the coloring of those bands to really show well. Kind of a fine tuning. You just play with it until you get it how you like it. This video is not meant to be a comparison video, but I did also want to point out that I did attempt to image Jupiter with the Seestar S30 Pro, and I did not have good results with it. I was only able to get the tiny bits of bands on Jupiter through the Seestar S50. And the reason I believe that that is happening is because of their aperture. The Seestar S50 has a 50 millimeter aperture, and the Seestar S30 Pro has a 30 millimeter aperture. Basically means that the Seestar's pupil is a little bit better at collecting light and getting a slightly better detail, especially at like really zoomed in targets. The Seestar S30 Pro has plenty of its own advantages over the Seestar S50, such as its ability to take star trail images, which I feature in another video. So be sure to check that one out if you're interested. But just be aware, as far as what I was able to do, I was not able to get a successful image of Jupiter, at least one that shows the bands from the Seestar S30 Pro. Now, for my final image, I did cheat just a little bit and went outside of the sea star to be able to build this composite image where I took an image of Jupiter that was blown out and bright, but where I could see the moon, and combined that with my image where we can see the very slight detail in the bands of Jupiter for this final product. I hope you enjoy.